Hello all, myself Suresh Kumar. This is our 9th class. In this class, we will cover about analog to digital conversion. What is an analog to digital conversion? In my case, a lot of people are saying analog to digital conversion. In my case, I said that processor or any digital device doesn't, or microcontroller doesn't convert anything. In my case, this is really important. You must need to know about that. That processor doesn't convert anything. That is generate equivalent to the analog value, analog signal. If you providing an analog signal, that processor have doesn't that microcontroller or processor have doesn't conversion part. It has it has some architecture that is taking the sample signal and generating a digital signal for the corresponding analog signal. This is called analog to digital generation. This is not analog to digital conversion. A lot of people are, the whole people are said analog to digital conversion. In my case, I said, definitely said, it doesn't have a conversion unit. It is generating equivalent to the analog signal. The generator is generate the digital signal corresponding to the analog signal. This is analog to digital generation. In this case, just think about it. You have a LM35 sensor. You are a beginner right now. So that's why I am choosing LM35. LM35 is a temperature sensor. This temperature sensor have a this temperature sensor working 0 to 5 volt. So we will provide the 0 to 5 volt for that sensor, and another one pin have an output pin. That is an output pin. We can use that pin into given the input for that our microcontroller in an analog port, analog pin, analog channel. If you just think about it, if that room temperature is 0 to 100 degrees Celsius, our sensor we are giving 0 to 5 volt for that sensor. If that room temperature is 50 degrees Celsius, that output of the sensor is 2.5 volt. You got it? Just concentrate, just listen. If you have a sensor, that sensor is providing 0 to 5 volt. Maximum is 5, minimum is 0, and our room temperature is minimum is 0, maximum is 100 degrees Celsius. If our room temperature is 0 degree, the sensor will provide 0 voltage. It will provide voltage. If our sensor will our room temperature is 50 degrees Celsius right now, then our sensor will providing 2.5 volt. If our room temperature is 100 degrees Celsius, the maximum of 100 degrees Celsius, our sensor will providing 5 volt to the microcontroller. If that room temperature is from 0 to 100 slowly increasing, the voltage level is also 0 to 5 volt slowly increased. This is called analog. It is corresponding to temperature or anything, pressure or force. This is corresponding to generate the voltage signal. Then we will get the voltage signal from that sensor and generating equal to the we will generating the digital signal equal to the corresponding to the analog signal. We will generate the digital signal corresponding to the analog signal. This is a analog to digital conversion or analog to digital generation. Okay. Now I am going to explain about. I am going to create a project for analog conversion. I don't want to explain those previous steps because that is same for every project. All projects, project creation and making source file, those are same, but the code and design is different for every classes. Okay, just click it. Already running it. Project, go to new project, LOG analog, browse. I'm make a new folder, that is LOG analog. Okay, and save it. Project window. No. Save it, the same folder. With .c extension. Don't forget it. This is an important .c extension. Same thing, we need to add 16F877A.h. Use delay ck equal to 16 MHz set. I'm using 16 MHz. Out of this, externally connected with my processor, microcontroller. Yes, use fuses. No need right now to understand this. Fuse is last class. I will cover it. HS and no standard. Void main. Float ABC default. Setup ADC setup ADC all G analog setup set ADC. It. Just type it ADC. Setup ADC port all analog. Setup ADC ports ADC clock internal. Setup ports ADC clock. ADC clock internal. This is an internal clock for that conversion purpose. ADC internal, ADC clock internal. CC clock TDR internal. Set ADC to ADC channel. Channel 0 means ADC channel 0 which means ADC A0 pin. ADC channel 0, ADC clock internal, that's it. Value read ADC is a function of it. You can close it. This is the setup of our while on. ADC volt equal to ADC off. Printf. Value equal to slash %f slash r ADC ADC port lay is 100 or something. Okay, this is fine. So we'll finish it, and we need to add one more preprocessor directive as use res 232, which means the serial port UART serial port TXRS communication TTL BAU bar rate we set 9600 bar rate. This is a default, and XMIT, which means transmit pin C6. I am using C6. We can use any pin. Okay, I will save it. I didn't add it, just add it. Source, and then click it. Okay, expecting declaration. Where it is? Read REAB. ADC volt. Set ADC. Setup ADC. Undefined. Where is that? ADC volt. It's not an issue. Yeah, it's built successfully. Then we need to go to where it is. Just put it 877A processor. It doesn't responding. Just providing 16 MHz. Then click OK. This one LM35. Okay, save it, just close it. We don't want this file right now. We can access from this our MPLAB IDE. Just close it and go to PROTEUS VSM, then open it. There it is. Open design, open. We got it. Here it is. We'll compile again. We will build again. Just run it. You got a virtual terminal. Just click it. It is equal to 14 point something. You just slowly increasing. That is also slowly increasing. This is corresponding to generating the digital value for analog signal. This is called analog to digital conversion, not conversion in my case. Analog to digital generation, corresponding to generate the digital data. This is the analog value, this is the digital value, this is an output of digital value. You can convert any analog signal in this case, and then you write a code here, you write a formula for here. I just make a voltmeter for you. Next class I will make a voltmeter for you. Maximum is 150, minimum is, you can see it, slowly increasing. Here it is slowly increasing, like I'm slowly increase that sensor. There is also slowly increasing. This is the analog to digital generation or conversion. Thank you for watching. Please subscribe my channel.